That's better than having less than half of the people show up. All right, guys, all right, first thing is, let me see. Well, let me do this. Any questions from homework stuff? Oh, I'm showing you how bad is my kitchen? It's pretty bad. Here we go. That's why I put my whiteboard there, so I cover up whatever's going on behind it. Any questions from homework stuff or?
For section 2.5, where we had to find the mean, median, and mode. So for the median, I just looked at the textbook and just found it from there. But you said to show work. Did you want me to write down all the numbers on the paper and then show you how I found the middle? Or
yeah, if you want to do it that way, then that's what you got to show me. Yeah.
Okay.
There's a quicker way to do it that we discussed, but if you want to do it that way, then that's the work you got to show me.
Okay.
Yeah, one big takeaway from that question is show your work. Another very disturbing thing to me is the number of people who are obviously copying from the solutions manual. You guys do not copy well. I find it disturbing and adorable how bad of a job you do in rewording the answer so that it's not directly copied. But when you don't understand what was written in the first place, your rewording doesn't make any sense. So, yeah, so stop doing that. I almost feel bad for you if you have located like a solutions manual that shows you all the answers, because it's going to be hard for you to stop looking at that, but it's not doing you any good. All right. Homework altogether is worth less than a fourth of the amount that the midterm is worth. And it's worth even less than the amount that the final's worth. And it's worth less than the quizzes together are worth. So anyway, sorry. So that's my little public service announcement on that. So please, dear God, make your mistakes, make them honestly, make some mistakes. That's what the hell it's all about, making mistakes. You do something, you make a mistake, I say it's wrong, you ask questions, you learn why it was wrong, and you understand it better in the end, right? Just copy down right answers from somewhere else, that leads to zero understanding. Makes no sense to me. Anyway, so that's happening far too much. I'm really concerned. If I've pointed it out to you already, and that means if you do it again, I'm just going to give you a big old 0 for the homework grade. And I just won't waste any more of my time looking at your stuff. Okay. Anything about that, or more people have come in? So any questions from homework or anything?
I have a question on 2.4, question 90, which is a box plot. And I'm really confused on how to set up the box plot for like the data that's given.
Let me see, number 90. Let me bring it up here. Oh, is that the, oh yeah, that's this one. Okay, I love you guys. I love you guys so much. All right. No, somebody's asking they're behind on homework by 1 assignment. No, that would never hurt you. You're fine. So this data here, can somebody tell me where's the data in this problem? Where's the data in this problem, number 90? You're welcome.
Frequency.
No, that's not the data. What's frequency mean?
How many times they said each answer?
Yes, and the answers are the data points. So what are the data points?
0 5 times, 1 9 times.
Yeah. 0, 1, 2, 3, 4, 5. I mean, sorry, 0, 1, 2, 3, 4, right? That's the data. So if on your box plot, it somehow goes up to 9, I'm not sure how that can happen, right? Because the question that was asked is how many movies did they watch? These are the answers to that question. This is just how often somebody said this answer, just like whoever it was just said, right? Sorry, I wasn't paying attention. Now, what does that have to do with anything? Now, let's do this first step together. Let me wrestle with my technology. Hold on. Bluetooth mode. Okay. How do you find Q1? How do you find the first quartile? What do you do?
Multiply
How do you find the
25%
first
by
quartile?
25.
Yeah, so to find Q1, I take 25% of how many data points I'm working with. And what is 25% of 25?
6.25.
6.25. Oh, I see. Okay. 6.25.
What did I-
And what do I do when I get a decimal? What do I do when I get this kind of answer?
You round
Don't
up.
you round up?
Round up to 7. So the 7th number is the answer. I shouldn't circle that because it's not the answer yet. The 7th number is the answer. How do you tell what the 7th number is from the way they've given me the data? Can somebody tell me what the 5th number is?
1.
0.
Oh,
The 5th number is 0. So the 6th, 7th, 8th, 9th, up to the 14th number is 1. So this would be, holy crap, what was that? This would be 1. Q1 is 1. Do you guys see what I'm saying? You don't have to write, some of you guys are writing 0, 0, 0, 0, 0, 1, 1. Oh my God, why would you? You can just count, it's fine. The 5th number's here, so the 6th through 14th number's here, right? So the 15th through 20th numbers are here. Do you guys see that? 5 plus 9 is 14. 14 plus 6 is 20. I don't know. Are you? I'm even that's more difficult than it has to be. I really want you guys with me. If you have to, you can write this big ass list, have 5 zeros, 9 ones, 6 twos, and count through it. But I really want you guys to see how you do not have to do that. Does that help at all? So the process of how to find the quartiles never changes. Never. So Q2 would be half of 25. What's half of 25?
12.5.
12.5, round up to 13. The 13th number is Q2. The 14th number is still 1, isn't it? So the 13th number is still 1 also. So Q2 is also 1. All right, that's all the work I'm going to do for you. Okay. Is that all right? So the process of how to find the quartiles doesn't change. The way that they give me the data could change, but the process doesn't care about that. All right, let me see. Somebody else had a question. What was it? It was number 86. Yes. So this is where things get weird. Everybody knows this. A lot of people know this problem. See, what is it about China? What's happening with China? It's not that they don't have a box, to be honest. They do.
Not that many 20-year-olds are traveling.
Well, I don't know, to be honest. I mean, almost everybody could have went to 5 countries. Where's the box? See, it's not even what's in the box. It's where is the box, right? Where is the box? Somebody help me out. What does this line here mean? What's missing here? What's missing for Germany?
Yes.
The second quartile.
Yeah, why is it not really missing? It just happens to be the same as what?
The first or the third.
The third. It's the third because it's dotted, right?
Yeah.
So this is the second and third. Didn't we just calculate on that number 90? Didn't we have the same answer for Q1 and Q2? So you're going to have a dotted line because they kind of overlap each other. Now, what they didn't do at all good enough here was for China. What this must mean is either Q1 equals Q2 equals Q3, and that's why they're all shoved here. And then this is the high. Do you guys understand that? Is it impossible for the low to equal Q1 to equal Q2 to equal Q3? Is that impossible? No.
No.
Because I could have data. Stay with me now. I could have data like this. 8, 8, 8, 8, 1,000 eights, and then a 10. So the high is 10, but Q1, Q2, and Q3, and the lowest is 8. Does that make so? You have 1,000 eights.
So the plot just means that not enough people have visited other countries, so it's just statistically insignificant.
No. I know what you mean. So this could mean that. All right. So the way that they actually mean it, looking at the solutions, is they meant this to be the dotted line. If they would have made this a dotted line, then you would have known that 0 is the low, 0 is Q1, and 0 is Q2, and 0 is Q3. Woo! So that would have meant that you ask somebody in China how many countries have been in. None. How about you? None. How about you? None. How about you? None. How about you? None. Until you finally, there's one guy maybe said 5. Does that make sense? Are you guys with me?
Yeah, so it just means that there was so little variation.
Sure. Or just a lot of people said 0. Yeah.
Can you say that again while sharing your screen? Like,
I am sharing my screen. Can you guys see my screen?
We can see it.
oh, I
Okay.
can't.
You gotta
sorry.
select when
yeah,
you're
sorry.
viewing him.
Oh, okay.
Are you on the phone or are you on a?
Yeah, I'm on a phone. I see it
Oh,
now.
I'm
Sorry about
Okay.
that.
Phone is always sucky. I've only been on a phone once on Zoom and it sucked major. I'm sorry. Now I've got like 2 monitors, so I'm like, hell, I'm majorly advantaged. Okay. Does that help with that at all? So, I mean, you're right. There's not much variation in the answers, but, you know, it's just because a lot of them said 0. Yeah. Does that help you guys out? You guys all right?
So okay, sorry. So when answering it, we can just say that it's not we can't say it's possible. We're saying that the low Q1, Q2, and Q3 are the same. I'm
Yeah,
just trying to figure out the best words to put it together.
so the actual question, I think part A, let me clear all this away. Part A said eyes didn't clear it all away. Hold on. Bam. Describe what the shape of each box plot implies. So the shape, so a lot of you guys were saying there is no box plot for China. Yes, there is. It's right here. The fact that there's no box showing up means that there were a lot of the same data value. When you see this, can you tell if they're all down here or if they're all up there? No. So that's where I would be okay with you saying there were a lot of the same data value. I can't tell if they were 0s or 5s.
Oh, okay.
Yeah, it's not even across the board. I really want that. Everybody said this, and then a few people said that, and there's really nothing in between. If there was stuff in between, then it would have looked more like Germany or United States. There must have only been extremes. That's pretty much the only way you can end up with something like this, where it's completely collapsed on one side. Okay. Is that better for that problem?
Yes.
A little bit? Okay. All right.
So for my assignment that I submitted, you gave me the okay, that it was like okay, but when I looked at the grade, it said that it was incomplete. So do I redo it and resubmit
Oh,
it?
hold
or-
on.
okay.
Let me see who's talking to me, Sean. So here's the unfortunate truth sometimes. There were so many people where the correct grade was incomplete. I'm sorry to say that I do sometimes hit incomplete out of habit in the, so let me see, I might have done that to you.
It's okay. I just wanted to make sure whether to redo it or not.
Yeah, yeah. This is what again? 2.4?
Or
2.4?
Mhm.
All right, let me do this real quick. I'm thinking about it. If that ever happens to anybody else, if I say okay at the top of your paper and I give you a grade and I say incomplete, then that means something, I made a mistake. Yeah, so this should be complete. Okay, I changed it. Thank you.
thank you.
Sure. It's very weird grading on a computer. When you're doing things on a computer, you can kind of get stuck in doing the same thing over and over again. So I've done that a few times. All right, anything else from homework stuff? Okay, so, problem 23. Let's see. Is that the one with the ranking, the dude that's ranked? No. Oh, this is just, okay. So what's the trouble with this one? What's the issue here? No? Hello? How do I find? Oh, I don't give a shit. So listen, 23 is a beautiful example where the back of the book has the wrong answer. That's why I love problems like number 23. So yeah, it's just going to happen. Did you ever see a typo in a book that you paid $150 for? Yes. How much did the typos in this book cost? 0. So, I mean, humans are humans. We're going to make mistakes. It's actually not necessarily a mistake. They're just doing it a way that's not good. So you'll get a different answer for 23B if you do it the right way. So is that all right? I mean, you're all right. I don't like that answer. So let's see. Well, let's make sure that you're right, because no matter which way you did it, you should have got the same answer for 23A. So how do I find the 40th percentile? What's the steps to find the 40th percentile of any set of data? Man, I'm having a rough technology day. Yeah, 40% of 29. I like it. This is trying to be a number 2. So 40% of 29, what do you get?
11.6. 12.
So then the 12th number is the answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you get 37. That's the same answer the book got. Yay, book. Now, part B, they get a different answer because they do it the wrong way. So you do it the right way and you get the right answer. And then everybody's happy.
We write the P40 equals 27, right? And P 78.
Yeah, this will be P40. I like it. And now you do this the same exact way. No worries. Dooba-dooba-doo. So the book does it a different way that doesn't make any sense. And you can do it their way if you want to. That's fine. But if you do it the right way, then you're going to get a different answer for part B. Is that all right? You guys okay out there? So there will be actual typos. There will be, because there's typos in everything. There will be times when the book does it a way that's either overblown or just doesn't agree with the way I do it or whatever, right? And again, you could do it the way the book does it. That's fine. Anything else, guys? Did I miss anything?
I had a question for 2.3 on 30. I got kind of mixed up because you know how, because I took the exam one as an example that when you want a higher percentile when you're doing an exam, but I wasn't sure how that worked for the
Listen.
salaries.
The question of what do you want is separate from what the percentile means. The percentiles always mean the exact same thing. 78th percentile means 78% of everybody else had a lower whatever. So in this case, what is it we're talking about? Salary. So 78% of everybody else had a lower salary.
I'll be pleased.
Is that good?
Yes.
Oh, yeah. Okay. Yeah. Makes sense. Thank you.
Okay. So I really want everybody to understand what I'm saying. Percentiles only ever mean that one thing. Then you can say, well, is it good or bad in this case that it's low or high, right? So there's a whole thing about time. Don't you want to finish a race in a shorter time, which means a lower percentile would be better? But does that change the meaning of the 10th percentile? No. If I had the 10th percentile time, then 10% had a smaller time than I did, right? Took less time. Does that make sense?
Yeah.
It always means the same thing. That percentage is below this score. That's what it always means. Is it good or bad? That's a judgment call we make.
I
Oh,
might
you're
make
okay.
this a lot longer than it should be. For me.
What's that?
I might make this a lot longer than it should be, talking about the same exact thing. Because that's why I understood from you, like everything below. Okay, so the question 25 made everything confusing for me because the way the solution for 25 that I got was 20% for the ranking.
All right, now listen. What is the best place to be ranked?
First.
Because then everybody else is below you, right?
Mhm.
So if he's ranked 37th, how many people are below him?
143.
There you go. 143 divided by 180. That's the percentile, because percentile is percent below a given location, right? A given score.
Mhm.
So in number 25, it was because ranking, how do I say this? Do you understand how one doesn't mean a low thing? It's actually the top, just because of the way we use the word ranking in English, right?
I understood the solution, but I think my brain is making it more complicated than it should be.
Were you the one that asked me if it was okay the way you did it?
Yeah. No, that was me.
For sure, I said that was
because
fine.
I saw the solution is that yes, I know that 80% makes a lot more sense than 20%, but that just made me confused with the rest of the assignment. But I'll talk to you later. I'll talk to you individually later, I guess.
So it's just, so percentiles only ever mean the percentage below somebody. And because a ranking is ranked, the 2 is below 1 and 6 is below 2 and so forth. That's why you got to think about 143 instead of 37. I mean, it still means exactly the same thing. Okay. So like, for example, in the race, the runner who came in the lowest percentile, right? They won the race, correct? So they would rank first place, even though they had the lowest percentile. So it's I don't know if that helps or hurts you, but it doesn't change what a percentile means. It's the percentage that was below a certain value. Okay, always. All right, anything else, guys? All right, let's do this. Let's finish this sheet. Let me put it up here. Let me see. Do I still have it in my calculator? Hold on. We did some of this in the calculator already. Let me see if I still have it in here. I think I do. I think I do. All right, here we go. You can do it. Come on, come on, come on. Come on, calculator. There you go. All right, let's see what's in you here. Bam, bam. Thank you, ma'am. I think this is, let me see. Yeah, remember, this is the data. So let me show you the problem again. So here's the sheet. It's up on Canvas. If you weren't here last time, does this sheet look familiar? Right, we put this data into the calculator. We sorted it. We did all this business to it. Let me write down here what our mean was. We got a mean of 6.5, didn't we? Which means it added up to be what, Jeff? Come on, math boy. You could do it. 6 times 13. It added up to be 78. Is that right?
Yes.
Thank you. All right, so let's stop for a minute. So on the other side of this page, there's an entire worked out problem. So here's what we did last time with constructing standard deviation, right? The average distance from the middle to all the data points. Oh, yeah, there's several. Can somebody look at Elena's question in the chat? There's one called,
Yeah, I got one. Let me find it real quick.
Wabbit, not Wabbit. What was it? Anyway, all right.
Your calculator's been acting funny. Do you guys know where I can download a calculator simulator for laptops?
I found one. If you look up, what is it? TI-84 SmartView, you'll find.
Oh yeah, you can sign up for like a temporary thing.
Yeah, it's like an 80-day trial, but
and then
it
you
only
sign up with a different email.
Yeah, just do the Netflix thing and you'll be good. I used that one for a while.
Yeah, that's a good one because that's an actual TI. It's basically the same one that I have, except I have a license for it and all that kind of stuff. Let me see. Where did I leave off? Okay. So we did an example. We did several examples of finding standard deviation. So last time, let me pull up my calculator again. We put into list 1, we put all the data, we sorted it. Then in list 2, we put, let me do list 2 again. In list 2, we put everything in list 1 minus the mean. Right? X minus X bar. I want to know how far away each data point is from the mean. Bam. And then, do you guys remember we have to kill these negatives? So the next thing we do is we go to L3 and we say, L3, I want you to be L2 squared. I want to kill those negatives. Bam. So you find the distance. Sorry?
Can you show like what you put in for L2 up top again?
Yeah. So L2 is supposed to be each data point X minus the mean. So where are all my data points? List 1. So I'm going to do second 1 for list 1. So L2 is going to be each thing in L1 minus 6.5.
Thank you.
Now this column will always add up to 0. So it's no good. I can't get an average from that then because it would always be 0. So we decided that we're going to square it, which means at the end, we have to square root. It all comes together. What's the fundamental thing we are trying to find? The average distance from every data point to the mean. Right? And that kind of makes sense if you think about it. How far the data points get on average from the middle is a natural measurement of spread. It just is. It's kind of beautiful. All right, and then I showed you a way to add up these numbers quickly. If you hit second mode to quit, you can go to list up here above. Uh-oh, I got a chat coming in. This is good. Oh, I'm sorry, buddy. Go to list. Go to math. So I can do some math. I want to sum up number 5. I want to sum up list 3. And that's where we got 69 from. All right, so that catches us up to where we left off. I'm going to stop sharing this. I'm going to go back to the sheet. Here we go. So then I take the formula. Oh, I don't have to do this anymore. What am I doing? Hold on, guys. There we go. Old man trying to do stuff. Let me erase this. So this, I know this is new to us. We're still new to this Greek freaking letter. What does that Greek letter mean again? Not the name of it, but what does it mean?
The sum.
I like it. Sum. All right, so everybody's trying to help out Anthony. I appreciate that. So this means sum. So the sum of these things, okay, I did that. If I add all these things, I get 69. So this is the first big hurdle for you guys to get over. Algebra is awesome. Algebra kicks so much ass. But in algebra, you're so used to plugging things in for each variable. But now this whole damn thing is this. Because when we added these up, we got that number. What does n mean? What does n always mean for us in statistics? What does n always mean?
The number of data points.
Yeah, number of data points. I had 12 data points. So 12 minus 1 is 11. That's where we got the 11 from. So somebody help me out. What is 69 divided by 11?
6.272.
It keeps going, right? Forever like that? Yeah. Okay. Now let me show you this. Is everybody with me? All right. I'm going to stop sharing. I'm going to go back to my calculator. I want to show you guys something. So once you do this, oh shit, where are you? There you are. Can you guys see my calculator?
No, you're showing the PDF with the answers on it.
Good job, Jeff. Here we go. All right, I'm going to assume you can see now. So 69 divided by 11. There's this. Now watch this. I think I showed you this before. I could do second squared to get square root. Second negative to get ANS. It's the last number that shows on the screen. So I could do that square root real quick. So what's my standard deviation?
2.504.
No. What is it? You guys are like, I don't want to say now. What the hell, man? It says 2504. No, 2505. Thank you. So we got to round correctly, everybody. 2505. Right? In case you forgot, you want to make this note again. You always round standard deviation to at least 3 decimal places. So this will be 2.505. All right, now just to remind you, I think I showed you this last time, but does somebody remember how to make the calculator get the standard deviation done for us quick? You go to Stat, Calc, because I want to calculate something now. I want to calculate one variable statistics. List one, calculate. There's my mean. Why does it give me 2 standard deviations? Crazy calculator. I love you guys. You're all like, I don't know, man. This is your thing, math boy.
One
So-
step and one sample.
What is that little circle one that mean that? Yes.
Does everybody remember what this means? What letter is that?
Mu.
No. U looks like a U. This looks more like a fat R.
A P. Or yeah.
It's a Greek letter. Lowercase sigma. It's standard deviation, but I think somebody just said it's for a
Population.
population. So our letter, S, is for a sample. Sigma is for a population. So this calculator is dumb. The calculator, everybody listen, calculator is dumb. It is dumb, right? And I'm just asking for it. This thing is going to stop working now, but it doesn't know. It doesn't know. So we know we put a sample in, so we have to pick the S. If you're doing work and you're doing a population, then you pick the little fat R dude. You guys understand? It gives me both because it's dumb. It doesn't know if it was a population or a sample we put in there. Is that cool? You don't get to pick. You pick the one that makes sense in the context you're working. So it's a sample. That's why it's 2505. All right, maybe. Okay, so looking back at the sheet. This is a neat idea. This is a huge idea. And I really want you to understand. So let's talk about this for a minute. This is very important. You guys are at the point, you should be able to tell me this. Let's see how lazy I can be. Which one is, oh God. Which one of these has a larger standard deviation? The first or the second one? Which one has a larger standard deviation?
The second one,
Yeah, why the second one?
it's more like spreaded.
It's more spread, exactly. Standard deviation fundamentally measures spread. So if I want to step around in my distribution, I'm going to use a standard deviation as my step size. I really want this to make sense. Standard deviation is a natural choice for how to measure how far apart things are. So would I use inches to describe how far apart planets are?
No.
No, because on average, how far are planets from each other? Millions of miles, right? You guys semi with me? If you know any astronomy, you might actually use something called an astronomical unit, which is the average distance from the Earth to the sun. But so there's an idea of, if I want to measure how far apart things are, what unit do I use? Do I use kilometers? Do I use centimeters? Do I use what? I don't know, right? And of course, in America, we go, metric. That's for every other country on the face of the earth, not us. Sorry, all right. So a standard deviation, once I calculate it, it is my natural choice for determining how far apart things are. So watch this. All right. if I have a distribution, let's say the mean is 10 and the standard deviation, let's say, is 2. How many standard deviations away is 14 from the mean? How many standard deviations away from the mean is 14?
2.
2. So be really careful. Never say this on a test or a quiz. Don't call standard deviation a step, but I will often refer to them as steps because it only makes sense. If every step I take is too big and they go from 10 to 14, of course I'm going to take freaking 2 steps, aren't I? Of course I am, right? Let me give you something more interesting. What if the mean is 9.3, the standard deviation is 1.072, and I want to know how many standard deviations away is 13. You're going to do the exact same thing you just did. It's just nothing you can do immediately. To determine how many steps it's going to take, what do I first have to see?
The difference.
Yeah, I want to see how far apart they are. So what I do, the data point, x, 13, minus the mean, 9.3. So once I know how far apart they are, what do I do to figure out how many steps fit into that?
Divide it by.
Divide it. That tells me how many steps away some data value is. So if your height was 3 standard deviations above the mean, you are freaking tall as shit, man. You are tall. People would do a double take like I did when I saw this ex-NBA player, Manute Bol, 7'7", walking around in the Southwest Terminal. I was like, whoa. Sorry. All right, maybe. So standard deviations, if your grade is 1 standard deviation below the mean, you scored below average, it's not good, right? So it's another relative, it's a measure of relative position. It's another way to do that. I don't know how good you guys are with this. Okay, all right, maybe. So let's come back to that page. Oh, this thing, by the way, this thing, I might as well give it its name. I don't think the book gives it its name yet. This is called a z-score. The z-score is the number of standard deviations from the mean to the data point. The number of standard deviations from the mean to the data point. That's all it is. All right, so let me come back. Is everybody ready? I'm going to shift over to here. Here we go. So let's finish this up. How many standard deviations from the mean to the data point of 8? So what would I do then? So it's always the data point minus the mean. So it'll be 8, and the mean was 6.5, divided by the standard deviation we just got. And what do you guys get?
0.599.
0.599?
Mm-hmm.
Okay, sounds about right, I think. Yeah, that sounds exactly right. I like it. Cool. Now, watch this. Part D gets really interesting. All right. So if I put the mean I found in the middle, makes sense because that's where the mean is. The mean is 6.5. If I take one step down, can somebody figure out what that is? One step. Don't tell me 5.5. How big is every step? Take one full step down. Where do I end up? Yeah. So you would take 6.5 minus 2.505, and you end up at 3.995. What if I take one step up? All right. No? Okay, I'll tell you. Is it 9.005? Yeah. So all I did was I started at the mean, and I went one step up and one step down. Can you tell me what percentage of the data I just caught? So did I catch the 2? Did I catch the, do you guys see what I mean by catch the 2? Did I catch the 2 in here?
No.
Nope, it's out here. Did I catch the 3? Is there a 3? No, I wouldn't have caught it anyway. How about a 4? I would have caught the 4s. I caught 4 up through 9. You guys see that? I caught all the 4s, all the 5s, all the 6s up to 9s. That's what I caught. So how much data did I catch? 1, 2, 3, 4, 5, 6. What was it? 4 to 9, 7, 8, 9. Is that right? I think so. I caught 9 data points in there. Do you guys see that? If I go one step up and one step down in this data, I happen to catch 9 data points. What percentage is that? I caught 9 data points out of 12 data points, right? And that's 75%. So I caught 75% of the data. And I know right now you're all like, okay, Jeff.
Wait,
But-
would it be 9 points or 10 points? I think you forgot to circle a point.
Oh, maybe I did. Let's see. No, 1, 2. No, I caught them all. Like I don't catch the 2 and I don't catch the 10s, right?
Oh, okay, I see.
Thank you. But yeah, keep an eye on me. You never know. That wasn't difficult, was it? It's not difficult. It's just different. And right now you have no idea what that problem even means. I understand. So let's talk about, go ahead.
Would you be able to find the percentage if you don't know how many, like if you have an indefinite amount of data points?
No, you could do it theoretically in some situations, which is where we're sort of headed. But you would actually have to know the complete list of data if you wanted to do it the way we just did it.
Okay.
Yeah. So let's talk a little bit about the theoretical part of this. All right. I'm gonna have to stand up. Oh man. All right. All right, so come back here. If I have a normal distribution, right? Which means in a normal distribution, it's symmetric. The mean equals the median equals the mode. What am I forgetting? Symmetric, the mean is the median is the mode. I forgot something else. Oh, well, too bad. I don't know. Today's a rough day. Here's what's got to happen. All right. This is very neat stuff. If I go up and down one step, let's see if you guys can handle this. So that would be mu plus sigma and mu minus sigma. Let's come up with a better way to represent up and down one step. Couldn't I just instead call it 1 and -1? Is that cool? You guys understand that? And then what would this be?
The mean. Oh, the
What would I
spread.
call it? What would I call it? 0, because it's 0 away from itself. So what I'm actually writing there underneath are the z-scores, right? The z-score is the number of steps. So that's got a z-score of 1, and that's got a z-score negative. So if I go up and down one step in a normal distribution, I will catch 68% of the data. Stay with me. I love it. I love it. And watch why this makes sense. You might say then, no, what if I spread this thing out, Jeff? What if I spread it out and so I can escape your stupid 68%? Stupid. And then I go, no, because then if I spread this out, what gets bigger? If I spread it out, what gets bigger?
The list of.
Say again, sorry.
I said the median.
No. If I keep it centered and I just stretch it on both sides, so the mean is the same, the median's the same, what measures how spread out it is?
The average.
No, the average
The min
is
and the max.
place. No, I love you guys so much.
Deviation.
Standard deviation, the thing we just spent all that time talking about. So what measures the spread in data? Standard deviation measures the spread in data. So if I do spread this out, like I'm trying to escape, I'm trying to get these things out of here, I'm like, you're not going to catch me. My step size gets bigger. So I still catch 68% no matter what. If it is normally distributed, so the peak is in the middle. Is that what I left off here? No. Yeah, peak in the middle. Bell-shaped, right? Peak's in the middle. It's symmetric. The mean is the median's mode. I have to catch 68%. Now, in the problem we just did, what percentage did we catch when we went up and down one step?
75.
75%. So do you think that was a normal distribution?
Yes.
So that's 75 equals 68. That's what you're saying.
Oh,
This is a
no.
class. No. Okay, there you go. Sorry. Okay. I like it. I like it. So if it's normal, there will be 68% of the data within one step. I like it. What about 2 steps? Well, that's going to be 95% of the data. So that's going to be -2 to 2. Now, let me ask you this. If I have a normal distribution, would it be unusual? Well, let me ask you this. How likely is it to have something up here or down there? What percentage is in here? 95. So what percentage is outside of there?
5.
5%. I love it, right? Okay, so that means that we can identify a very specific rule for determining what's unusual or even what is an outlier, right? Unusual starts at mu plus or minus 2 sigma. Oh, geez. It starts at 2 steps out. So if I was here, if this was height, we'll do height next. We'll do a specific actual thing with numbers, people might like that, then if I'm out here or down there, I'm either unusually tall or unusually short. It would be an outlier. Outlier. Okay. And then there is another one. You can go 3 steps. If I go 3 steps out, that's 99.7. I'm not as interested in that. I don't care. You almost catch all of the data if you go 3 steps up and down. So if on a test you got a z-score of -4, you scored way below average. That's bad, right? So yeah, so z-score is another, like I said, it's another way to do relative position. It's sort of like a percentile, but not exactly. Okay. Let's try a specific, concrete, physical example. All right, here we go. So the mean height of males in America, American male heights. The mean is 69 inches, and the standard deviation, I believe, is 2.8 inches. I don't know. I haven't looked this up in a long time. So now watch. Can you make this? Now watch how simple this picture is. Oh, by the way, it does have to say this, but we do know that they're normally distributed. We do know that heights are normally distributed, which kind of makes sense. Most people are in here. Very few people out there. I don't know what it is. Today's weird. Okay. So 69 inches goes right in the middle. Can you guys do the steps? 1, 2, 3 steps. 1, 2, 3 steps. Can you guys create those steps for me? Man. All right, I'm going to try to do this without assistance. So this will be, you add 2.8, you add 2.8, and you add 2.8. Is that right? All right. There we go. Is everybody cool with me? Is everybody with me? Everybody? Okay. And then down here, same idea. You subtract 2.8. Oh, shit. I don't know. Subtract 2.8. Is that right? Subtract 2.8. Is that right? Okay. No, that's not right. So it's 60.
60.
There we go. Thank you. Keep me honest. Now, can somebody tell me, first question, what percentage is between 66.2 and 71.8 inches tall? So underneath, I would put these to help me out. You guys see this? Because now I can just use the rule that you all have to memorize. Yes, you have to memorize the 68, 95, 99.7. So what percentage is between 66.2 and 71.8?
68.
68%, because it's within one step. So let me give you a more interesting question. What percentage are taller than 74.6? Jeff, you could do it, buddy. So let's work this out. There's several ways to do this problem. So I want to know this right here. I want to know that area. Is that cool? I want to know the percentage that are above 74.6. You're like, what the shit? I don't know. It's not my 3 rules you gave me. But so what percentage is between 63.4 and 74.6? What is this?
$95.
95%. So what percent's outside?
5.
So what percent's on that side?
2.5.
2.5%. There you go. So if I made a door, if I had a door into a room that was 74.6 inches tall, what percentage of men would have to duck? 2.5% of men would have to duck. Or, you see a pop their head. You guys semi with me out there?
How did you get?
Do you understand how? Sorry, go ahead.
How did you get 68%? I got on the first. I got lost.
So this is the rule we have to memorize. Within 1 step of the mean is 68%.
Okay.
I like it. How do I know I can use that rule? Because I told you it was a normal distribution. If it's not saying it's normal, I have no idea. It could look like anything. All right. So do you see how this, do you understand how, all right, airlines would like to know how wide they should make their seats. They control how many complaints they'll get from people about not being able to fit in their seat. They can take average hip size and standard deviation and figure out exactly what percentage won't be able to fit comfortably, right? So it's a thing about how much bad PR versus how many people do we want to squeeze on the plane. Do you understand? A little bit, maybe? All right, maybe. I don't know. That's one of the most fundamental uses of statistics. All right. So, let's see. Let me think. What do I want to do from here? I forgot. That's pretty good. I like that. So this kind of question could show up in section 2.7 related to this. And I didn't call this its name. The thing we're using is called the empirical rule. I don't know if you can see that green too well. It's called the empirical rule. That's the one that goes for normal distributions.
Can you say the percentiles again? Or the percentages again?
Yeah. Let me write it real quick. You do it in black ink. Let's see. Within one standard deviation, there's 68%. Oops. Within two standard deviations is 95%. And within three standard deviations is 99.7%. I don't know if anybody's old enough. That sounds like the old soap commercial. 99 and 4400s pure soap. All right, none of you guys are, so okay, fine. I got confused. Oh, now watch. Please let this make sense. Somebody's asking a question about this last problem. From the rule, we know this is 95, correct? Within two steps. So how much, if there's 95% in here, how much is outside of here? 5%. Cut that in half, 2.5%. Because this whole thing is symmetric. So if there's 5% total, there must be 2.5 on each side because they're equally sized. It's symmetric. Does that make sense, Antonella? Okay, I like it. We're going to do a lot more specific things with this in chapter 6, believe it or not. This chapter is not going to get too specific, so don't freak out yet. Not yet. Okay, so let me ask you guys a question. Let me see. Do you guys want to just push forward? I want to get into chapter 3 a bit. And then if we don't take a break, we can get out a little early. It's up to you. Or you want to take a break now? You guys good? I'm going to keep going? Keep going. Okay. Push through. No break. No break wins. Democracy. Yay. Of course, if I wanted a break, there would be no democracy, but it's all right. All right.
I have a quick question.
What's up?
How the percentage, the problem at the bottom is written, is that how we're going to see it written with the less than X, less, yes.
Yeah, so this just means X between these two, right?
Yes.
Yeah.
Okay.
So that is a way you could see that for sure, especially in chapter 6, once we get there. Yeah. Okay. So what we're about to get into, I think there's enough people here. All right, let's try this. Have I done this with you guys yet? Have I done the birthday thing with you guys yet? I did the first day probably, right? Because that's when I had the most people. All right. Have I done the Monty Hall problem with you guys yet? The doors and the goats. Have I talked about the doors and the goats? All right. You're all like, I think I would remember that. So let's talk about the doors and the goats. Sorry, sounds intriguing, right? All right. Do you guys know the game show Let's Make a Deal? Anybody? It doesn't matter if you don't. I'm going to tell you what. So next time I want you to dress up in your costumes. I'm joking. So in Let's Make a Deal, at the end of the game, they would pick the person that won the most, and they'd say, you want to trade in all your stuff to get a chance at, $100,000, let's say. And the person would be like, well, shit, yeah. And so what would happen is there would be 3 doors. 3 doors. All right, now I've already put the prize behind a door in my mind. So there's a prize, there's $100,000 behind one of the doors, and behind the other 2 doors are goats. And we're assuming that we didn't come to this game show to win a goat, right? Somebody pick a door for me.
3.
All right, first thing I heard was 2, sorry. So this is the pick. What is the probability that the person has won?
33%.
A couple things coming at once again.
1 out of 3.
1 out of 3, 11, which leads to 33.333%. Okay, so 1 out of 3, or roughly 33.3%. I like it. Become a thing. No, really? I cannot make the number 3. Is that a problem for a math teacher? Okay. It's just the number 3 that has a problem. Anybody have any trouble with that? Of course it's 1 out of 3, right? There's 1 winning door out of 3 doors you choose. So what is the probability that we did not pick the prize?
%67%.
2 out of 3, 11, or 67, 2 out of 3, or 66.666666666. All right. Now here's the way the game works. I'm the host. You pick door number 2. I then open door number 3, and I show you there's a goat. It's a spider goat. Spider goat. Spider goat. Just deal with my horrible. It's a mutant goat. All right, leave him alone. He's had a rough life. Then I ask you, do you want to change doors? And the question is, would it matter to change a door? Would it affect your chances of winning at all?
No.
And that's the wrong answer.
What? How?
Stay with me. Ethan, calm down, dude. We just now figured out that was the wrong answer. We haven't talked about it yet. I love it. Did you agree that nobody spoke up and said they had a problem with this fact? There was a 2/3 chance it was somewhere else. right? Why did I open that door? Most likely because the prize is here. I'm not going to open the door with the prize or the show is over. The drama is gone. Do you understand? So 1 out of 3 times you would have picked the prize, and I will tell you right now, the prize is here. You should have switched. Oh, well, too bad. 1 out of 3 times you would pick the prize. 2 out of 3 times you will not. So now watch. Stay with me. Let me try this. You ready? Let me try this. All right. There's 100 doors. Right? 1, 2, 3, 4, 99, 100 doors. You pick door number 2. I open every other door except for door number 1. Goat. Like, where did they get all these goats? Why did I not open door number 1? The most likely reason is because the prize is back there. Either you picked the prize in the first place, which has a 1 out of 100 chance. You guys with me? Or the reason I didn't open that one is because as a prize. How often will that happen? 99 out of 100 times. Whatever door I don't open is most likely where the prize is. I don't know if you guys get that or not. Now, some people don't understand. Go back to 3 doors. You pick this door, I open this door. You should switch. Does that mean you will win? No, because this could be the prize. There's a 1 out of 3 chance that's the prize. So there is a 2 out of 3 chance the prize is here. What you guys don't realize is when I open that door, that doesn't make this 50-50. Because I'm the freaking host. I know everything. I know where the prize is. That's why I opened that door. That's why it's not 50-50. Okay, that's enough. That's enough. The main thing to understand from this example, hopefully you guys understand the example. That would be fantastic. If you don't quite, you're in good company. There's a lot of people that don't understand this. And I hope the 100 one worked better. If there's 100 doors and you pick one, you did not pick the prize. You know you didn't. And then the host opens every other door and shows a goat. That last door has the prize. Holy shit. What's the chances that you picked the prize? 1 out of 100. So it's a much better chance that the one door, the guy who knows where the prize is, didn't open it, right? Because the prize is there. Okay, I don't know. That's enough. That's enough. Okay.
That was a good
That's cool.
example.
Sorry?
That was a good example. I liked it.
Yeah, that makes
Thank you.
sense. At the
Oh,
end.
good. Okay, thank you. I understand it is very counterintuitive because our brain says 50%. No, it's sort of like my little brother said, Jeff, do you still teach probability? And I'm like, yeah. And he's like, what the shit? Everything's 50-50, dude. And I say, Jim, do not become a doctor. I don't want you telling me, as I'm going on a doc, what's my chances? 50-50. No. Right? There's not a 50% chance it's going to snow here today because it's going to snow or it ain't. Is everybody with me? So our brain says there's 2 now, so it's 50-50. No, brain, that's not how that works. They're not equally likely. Okay, maybe. And again, does that mean that if I do switch, I will always win? Of course not. You just increase the chances you'll win. Is that cool? Maybe. Okay. So this is just an example of how probability is not hardwired in our brains because we do not have to understand higher level probability to survive, right? Anything hardwired in our brain is most likely there because of evolution making it so that we actually survive, right? The only thing I had to know was, oh shit, saber-tooth tiger's probably eating now, so I don't want to go that way because that's where they go to eat. probability is I'll die if I go that way. I mean, that's not really a history lesson, kids. I'm sorry. All right, now. So let's talk about probability and then we'll call it a day. I want to immediately jump in to an example that I love. I give this kind of problem on every probability related thing, basically. So what is this going to be? Man, all right. Today is just that kind of day. Come here. All right. So here's the kind of problem I'm talking about. So let's say, let's make this Democrats, Republicans. So I have a bunch of Democrats and Republicans. I asked them a question.
We can't see the top of the board, I don't think.
All right, hold on. Okay. Thank you. Let me give myself some room out here. So I ask a bunch of Democrats and Republicans a question. They say yes, no, maybe. So let me start filling this thing in. All right. Can somebody, let me let you guys finish copying this. Can somebody tell me what this means?
Maybe.
More than that.
6 people.
6 Republicans said maybe.
Good. 6 Republicans said maybe. So these 6 people are Republicans and they said maybe. I love it. How many total people said yes?
2.
No. How many total? Now I'm a little concerned.
41.
You're like, sorry. I really appreciate it. Well, these aren't really people. No, let's not go down that road. I don't think that's what you meant. All right. I love it. So 2 and 39. So 41 people said yes. How many said no?
10. Wait, no, 45.
Okay. And then you have ESB, you're ahead of me. There's 10. How many Democrats did I talk to?
47.
47. How many Republicans did I talk to?
39.
39.
49.
I love you guys. And then how many total people did I talk to?
96.
Good. 96. This makes 96 and this makes 96. Why wouldn't I add these people to these people?
Because they're the same people.
Because these people are these people. Is everybody with me? Maybe. So let me ask you a question. Here we go. What is the probability if I pick one person from this group? What's the probability I pick a Democrat? So how does probability work? How many chances do I have to get a Democrat? 47.
47.
Out of how many total things could happen? 96.
96.
That is how you always do any probability, believe it or not. We're going to get more complicated probabilities, but I want to show you how they all boil down to what I just said. The number of things that match what you're looking for divided by the total that could have happened. So the bottom for this problem will always be 96.
Could you say that one more time? The number of.
Oh, okay.
I'm
I
writing it
didn't
down.
finish that next sentence quite yet, but a probability is always the number of things that match what I'm looking for divided by the total number of things that could happen. If I pick one person, it could be any of 96 people, right? And out of those 96 people, 47 match Democrat, match what I'm looking for. So the bottom will always be 96 unless I give you more information. So what's the probability I pick somebody who said maybe?
And out of 96.
Say again, sorry.
10 out of 96.
10 out of 9. Oh, and let's do this. What is 47 divided by 96? Give me 4 decimal places, please. Rounded to 4 places.
0.4896.
4896? Is that what everybody got? Okay. Can't be bigger than 1. Be careful there. And what about 10 divided by 96? 10 divided by 96. Will it be 0.11 something? No, just guessing.
0.1042.
Okay. I like it. So we are going to be rounding probabilities to 4 decimal places. Oh, because we're crazy. Because it's an arbitrary rule Jeff has made that you must do because I'm a teacher and you got to do it or else I'm going to fail you. No, I'm joking. There's a reason for it. We'll see. All right, let's ask a more interesting question. I gave myself no room. What is the probability I pick somebody who is a Republican or they said no? Okay, this should be interesting. What goes on the bottom?
96.
96, because I didn't tell you anything about the person. I just want to know what's the probability it's a Republican or they said no. How do I do that?
Add them both together. Add the people who said no and add the Republicans.
So if I do 49 Republicans plus 45 people who said no, is that correct?
No. Wait.
No, what? Go ahead.
No. You add
So
the
if I
people who are
do-
Republicans and the Democrats who said no.
I got you. I love it. So I could do this way. 49 plus 45 Republicans plus no's, but then I got to subtract off how many? How many people did I count twice?
4.
I counted 4 people twice. So what you're talking about is you could be smart about it and say, okay, 49 people plus the no's I haven't counted yet. You guys see that? 49 people plus the no's I haven't counted. Isn't that what 45 minus 4 is? So the math don't give a shit which way you do it. You're out there. I know math doesn't care about me. All right. So it'll be 49 plus 41 divided by 96, which is 90 out of 96, which is, I don't know. I don't know.
0.9375.
9375. Okay. You can make that into a percentage after this if you want to, right? You could make this 10.42%, whatever, right? 93.75%. Okay. Yeah. So notice how the or problem was a little more, you had to be careful about it because you didn't want to double count anybody. Now here's one that's actually easy. Let's see if you guys can get this one. What's the probability I pick somebody who is a Democrat and they said yes?
$47 plus 39.
Say again, sorry.
47 plus 39.
No. Careful. All right, so here we go. You ready? All right, let's say you're going to a bar. All right, and there's a bouncer in front of this bar. And there's 2 bouncers that work there. There's a nice bouncer and a mean bouncer. The or bouncer is the nice bouncer. The or bouncer says, you have to either dress nice, shit, be rich, shit, or you have to know Joe the bartender. I know Joe the bartender, I go in. Or is you only have to meet at least one of the requirements. So it's very inclusive, or makes things bigger, or lets more people in. The and bouncer says, all right, you got to know Joe the bar. I know Joe, and you got to dress nice, and you got to be, oh shit. You could have stopped at the second one. You guys understand? All right, now you're all like, that was a great story about bouncers, Joe. What does that have to do with math? So and means you have to match both. How many people are Democrats and they said yes?
2.
2.
2 people out of
96.
96. I love it. And then whatever the hell that is. Nobody's gonna help me. Okay.
2.08%.
Thank you. Cool. Okay. So the last question I want to ask you, that was question 4, question 5. Last question I want to ask you, and then I have one thing to say about the or, and then we'll call it a day. Here's the last question from this. What's the probability that I pick somebody who said no, given that they're a Republican?
Out of 49.
I like it. So it's going to be out of 49. Why do you say that?
Because of the given that they're Republican.
Good. So people read this wrong. It's the probability that they said no, given Republican. This is what I know. The second piece is what tells me what goes on the bottom. So I know they're Republican, so I can throw everybody else out. I'm only talking about these 49 people. Out of those 49 people, 4 of them match with what I'm looking for. So the only time the bottom is not the total is if I give you more information, because then I could ignore some other people, right? I really want that understood. And then that is something, 0.0805. I don't know, making that shit up. What is it?
0.0816.
Dang it, I was nowhere near. I'm sorry. Okay. So the last thing I want to say for today is I want to look at that or and make a general formula for or based on what we did. All right. I'm going to erase the chart, which is probably a bad idea. It's too bad. I don't have a big enough whiteboard. So how did we do the probability of something or something else? We did, what was 49 out of 96? That's the probability of Republican, right? You guys with me?
Mm-hmm.
So this would be the probability of A plus, that was the probability of the second piece, right? That's the probability of no. So that's plus the probability of B minus, what was the 4?
The Republicans who said no.
Yeah, the Republicans who said no. Minus the probability of A and B. So that is the official formula for or. I want you to realize something. Did I have to know that formula before we did an or problem?
Not really.
So probability formulas are only required when I don't give you everything that you need to count. With a chart, I can just count. I don't need formulas. I can just do what we did. It's simple. When do I need the formula? When I give you a problem like the probability of B is 0.7 and the probability of A or B is 0.2 and the probability of blah, blah, blah. And then you have to throw shit in and do algebra. And yes, that problem's coming. Yay.
No.
So that's our first official probability formula. Go ahead, sorry.
No, you said yay. I said no. Sorry.
I understand. I was being sarcastic for you guys, but For me, it's like, yay, algebra. I missed you, algebra. How you been doing? I've been making people's lives terrible. Oh, good, algebra. You keep going. All right. Otherwise, I think that's enough for today. So let me know if, oh yeah, by the way, I already put this up here because I thought I was further along, but you might as well take a look. You could go ahead on Canvas. There's a practice probability sheet, and it includes a practice quiz. Because when is the probability quiz? That's not for a while. Our next quiz is this Wednesday. Remember that? Next quiz is this Wednesday at chapter 2. I did post the solutions video for that 2.1 through 2.6 worksheet. So that's up on Canvas. What else am I trying to say? The next quiz after that, I believe, is the following Wednesday. Is that right? Or am I crazy? Well, let's see, Jeff. I don't know. I made the timeline. Doesn't mean I remember what it was. Yeah, it is.
March 3rd.
March 3rd. That's the next Wednesday after this. So next week, we have another quiz on the 3rd that's on chapter 3. We're going to finish up chapter 3 this Wednesday. And there is a practice quiz that I will put its own solutions up for that later. So we're definitely not far enough along to really be able to do that entire sheet, but you can take a look at it if you want to. All right. Otherwise, that's plenty. Sorry. Say
On
again?
our sheet, it says March 8th.
March 8th. Wait a minute. No. Remember,
Quiz 3.
here's the quiz date right there, March 3rd.
Oh.
This is the date we're going to be in chapter 5.
Oh, okay.
I don't blame you. Have some optimism. I don't blame you.
Water drips on it.
All right, guys. So go forth, do homework. Let me know if you have questions. Don't forget about my extra office hours that happen on Tuesdays and Thursdays. And obviously, don't forget about my office hours right before class, 12:30 to 1:30. Come on in. All right, guys. Let me know if you have any questions. Otherwise, certainly, I love to talk about goats and doors anytime I can. Spider goat. Spider goat.
I was looking in the modules and I saw that you had a practice for 2.1 through 2.6. Is that like a study guide, I guess, for the quiz Wednesday?
Sort of. Of course, the quiz is going to include standard deviation also, but I figured we had its own little worksheet and all that kind of stuff. So I made that one specifically for 2.1 through 2.6, and you can look at it and do it or not. And I did put the solutions up here, right? I said I did. Did I actually do that? Okay, thank God. Yeah. Whoa, what the hell? Where am I? There I am. There it is. Yeah, it's a video even. Oh yeah, it's from last semester. So if I don't know if I say anything about last, I don't know. I think anyway, it doesn't matter. It's all the same problems.
Okay, thank you.
You're welcome. Yeah, of course. The quiz is on chapter 2 and standard deviation is in chapter 2.
So it's including everything we learned today is on the test, on the quiz.
I want you to understand, we learned standard deviation last time. We just finished up an example that was on a worksheet. That's all we did today. We learned it last time. Yep. So it will definitely be on the quiz on Wednesday. Anything else, guys? Are you guys good? I'm going to head out if I don't see anybody else with questions. Okay. See you guys.